Let's take a look at OpenMP. OpenMP is a language extension for compiled languages such as C, C++, and Fortran for parallel programming in a shared memory environment. OpenMP has been around for more than a quarter century, and it's really an industry standard now. And it is really simple in the sense that to parallelize a certain block of code, for example, a loop, you will need to include that loop into an OpenMP pragma statement. So it's a compiler directive approach. You will typically find some piece in some block in a code that needs parallelization. Then once enclosed in this pragma statement, that loop will run in parallel if you have multiple processes available to you. At runtime, your code, if it knows that, let's say you have 4 processes available, it will actually launch 3 additional threads. So there will be 4 threads in total, and each thread is going to run on its own processor. So this is still a single Unix task. Just a reminder, in Unix, a task is the smallest independent unit of computing. So a task is typically a program, is independent program that has some memory space allocated to it. And then inside of that Unix task, you can have multiple threads. So these multiple threads can run on different processes, but all of these threads in a single Unix task will use the same shared memory space. So they will talk to each other via memory. And then when you have multiple processes available to you, then this shared memory code will launch multiple threads. Each thread will run on its own processor. So that way they're running in parallel, and your computation will be faster than if you're doing that in serial on a single processor. Then once that piece of code, that block of code finishes executing, then all threads but the main one will get killed. And then you'll just, again, a single thread that will keep running until you hit another parallel statement that was parallelized with OpenMP. And then it will launch multiple threads. Each thread will run on its own processor. So your code will run faster than on a single processor, and so on until you hit another parallel region, etc., etc. So this way, an OpenMP code can run faster than a serial code. But again, by design, this type of parallelism, shared memory parallelism, is limited to a single node.